Thank you. So for the last 9 years, we've underestimated the impact of a common class of vulnerabilities in PHP applications. Hundreds, probably thousands of instances of this issue have been found. And we've overlooked a simple behavior in PHP which exposes them to exploitation through unserialization. My name's Sam, and one way or another I spend a lot of my time exploiting web applications. Attacking web applications. So what I tend to do is ask myself, what vulnerabilities does this app have, and what's the impact of exploiting those issues? The research I'm going to talk about today doesn't have much impact on the first part of that question, so I'll be talking about vulnerabilities that you probably thought you already knew about, but I'll be giving you a different answer than you might have expected for what the impact of exploiting them is. So before I talk about my own research, I think it's really important to say that this is really just a tiny addition to some wonderful research done by a man called Stefanessa about 10 years ago. So he discovered this issue in PHP with unserialization. And so serialization is, for those of you who don't know, really basically, it's basically a process by which PHP converts internal objects into a string representation that can be stored in a database or passed over the wire, and then converted back to an object in PHP. The examples on the slide are really simple, so I've just given like an integer and a string, but it can deal with much more complicated objects. And what Stefanessa realized was that there's a technique quite closely related to return-orientated programming called property-orientated programming, whereby you can construct sort of a malicious object that, if you get everything right upon being unserialized, will sort of cause a chain of methods to be called and cause something malicious to happen. So as the issue is traditionally understood, there's a function called unserialize on PHP, and that's called on some data. And as I mentioned, basically certain methods are automatically invoked upon unserialization. So there's a method called wakeup, which is called whenever an object is unserialized. And there's also a method called destruct, which is called whenever an object is destroyed. If we get things just right, basically we can sort of chain together certain objects so that something nasty happens. If you're not familiar with that issue, I can't encourage you enough to sort of read Stefanessa's research. I gave a talk myself here 3 years ago, I think, sort of covering a lot of the same material. But for the rest of this presentation, you'll just have to accept that unserialization is bad. Okay, so what am I going to go through today? I'm going to start by talking about something called Stream Wrappers, which is a functionality in PHP which basically can be triggered on any file operation. And I'll go through a bunch of those, and we'll end up focusing in on what's called the far stream wrapper, which deals with a type of archive called a far archive, which is sort of supposed to be the PHP equivalent of jar archives. I'll talk about something called far planting. So we're going to need to get one of these archives onto our target system. The easiest way is just to upload one if we've got that functionality in the app, but there's a couple of other things we could look at if we can't do that. Identifying the type of vulnerabilities that are affected by this issue. Then I'm going to talk about, there's a really nice tool called PHP GGC. The GGC is for generic gadget chains, by a guy called Charles Foll, who works for Ambionics, I think. And that's sort of why so serial for PHP, if you're familiar with why so serial in Java exploitation. And he's kindly given me permission to release a branch sort of alongside this talk, which uses some of the techniques I'm talking about to embed some of the payloads that are already included with that tool in a far archive. Then I'll go through a number of case studies, talk briefly about how we could defend against this issue, and then a few things to take away. Okay, so the first part of this talk is essentially adventures in reading the PHP manual. And I came across this cartoon, which might not make that much sense at the moment, but we'll go back to it after I've shown you some stuff from the manual, and then it will hopefully make more sense. Okay, so this is the page in the PHP manual which describes stream wrappers. So essentially it comes with lots of these built-in stream wrappers, and there's a list at the bottom of the ones which are enabled by default. And they're triggered by all sorts of different file operations, so opening a file, checking if a file exists, copying a file, that kind of thing. These have been used, other stream wrappers have been used in lots of different sort of exploit techniques. So you'll hopefully be quite familiar with the remote stream wrappers, which I've grouped here: file, HTTP, FTP, and data. Data is not strictly remote, but it does require this setting, allow URL if open, to be true to use it, so it sort of falls neatly into that category. So these are the stream wrappers that essentially you use to access external files from PHP. So it can turn a local file include into a remote file include. If you can provide like a HTTP URL, it will go off and grab that file and include it as code. Often these are the things behind server-side request forgery issues. So for instance, if we've got a call to file get contents and we control the argument, we can give it an HTTP or an FTP argument and it will go off and get that file. And finally, they're activated by XXE, so XML external entity issues. The next stream wrapper I wanted to talk about is the PHP Stream Wrapper. So that's often used, for instance, in local file include exploits. We can use php://input to grab standard IO, which will be what we've posted to a page if we're, if PHP is running as a web server. There's quite a neat technique you can use to read the source code of a file with a local file include, because this stream wrapper includes some filtering functionality. So if we included a PHP file from another PHP file, it's going to try and run that. But if we want to read the source code, we can base64 encode that, then include it. And then on our end, we can base64 decode that and read the source code. Stefanesso used a really neat sort of variation of this on one of his early unserialization exploits. So he was able to put together a chain which would write arbitrary data to a file, but there was a prefix on the file which was PHP die, which would stop any code after that from running. But what he managed to do was essentially base64 decode everything before it was written to the file, and that sort of nullifies this header, and then he could prepare his other data to write anything to the file. The next stream wrapper is glob. Whenever I come across this, I think it's going to be really useful, but it works differently from the others. So you can't, for instance, call file get contents glob and then a path and get a listing of files. This is the example from the manual of how it's used. So it's used with a directory iterator there. And there's a page in the manual that lists all the operations supported by any stream wrapper, and the glob stream wrapper literally supports none of them. So there's two stream wrappers left, zlib and far, which are both related to archives. So if we're looking to exploit those, what we could think about is if there's issues in the native code. So maybe we could supply sort of a malicious archive and try and trigger some memory corruption or something like that. That's going to be quite difficult to exploit sort of in the presence of modern mitigations like ASLR and DEP. Now, obviously, there's something else here, otherwise I wouldn't be giving this talk. So we're focusing on the far wrapper, and within the manual, it lists everything that's in a far archive. And the first thing it lists is quite interesting. So there's something called a stub, and the stub contains PHP code. So immediately as an attacker, we think, well, can we get it to run that code through the stream wrapper? So I wrote a simple test program to set the stub to just echo something out, and then to access the file through the stream wrapper. And unsurprisingly, it doesn't trigger that code. And just to sort of confirm that everything was working as I expected, we can execute that archive, and the stub does get executed. Now, as best as I can tell, essentially that's the only circumstance in which that code gets run, if we access that file as an executable. Not wanting to be deterred, we move on to the next element of the file, and there's something called a manifest in all file archives. And if we look at the manual page which lists what's within a manifest, there's something very interesting in there. So we can have metadata in this archive, which is contained in the manifest, which is in the standard serialized format. So sort of again, not expecting it to work, but we may as well try. I constructed a simple sort of test program. So we define a class called test object, and we set the metadata to an instance of this class, and then another test program, which again defines this class, but also has a destructor defined this time, so that if the object gets unserialized and destroyed, it should trigger this code. And we're going to access a file in the archive. And surprise, surprise, it actually does work. So if we can put serialized data within an archive and then access it through the stream wrapper, that will be unserialized. And if it hadn't been so obvious, you would have gone something like that. Okay, so just to sort of confirm that everything was working as I expected, I've made a couple more test programs. So instead of getting the contents of a file within that archive, we'll just check whether the file exists. And also we can check whether a file that clearly doesn't exist exists. And both times the destructor still gets called. So hopefully now that makes a little bit more sense. So from this sort of obvious attack methodology emerges with sort of two parts. So we need to get one of these archives onto the target, and then we need to reference it through the stream wrapper to cause our payload to be unserialized. And this is quite similar to local file include vulnerabilities. So in that case, we need to get a file onto the target and then include the source code. So if you are familiar with the sort of standard unserialization issue, there's a couple of differences to be aware of. So when a normal unserialization issue occurs, the application is very deliberately unserialize something and then does something with it. So it's often easy to access a number of magic methods. So not just this destruct and wake up. For instance, there's one called toString. So we could, try and trigger a chain that way. In this case, the application's not really had any intention to unserialize anything. So we only have destruct and wake up to start our chain from. And there's a sort of a quirk that means within a destruct chain, we've lost the current path. So any file operations we do within that chain, we need to use absolute paths. Okay, I showed you a lot of copies of this slide with the different elements of a file archive. The third element is the file contents, which I hope is obvious. The fourth element is a signature, which it says is optional, but by default, PHP will only access one of these archives if it has a valid signature. So that's not optional to us as an attacker. Okay, you've probably seen enough of the manual now, so I'm going to take a few things out of it, and hopefully you can trust me that this is what the manual says. There's 3 valid formats for a far file, sort of the base file format, tar format, and zip format. For now, I'm going to ignore the zip format, so that might be useful if we were attacking a system which had some legitimate functionality which allowed us to upload a zip file. But far and tar both have some sort of interesting flexibilities in their format that could be exploitable to us. So we'll start off with the base far format. I've done a sort of a little hexdump with all the different elements in it. And if I can, I don't know if I can zap from here. Yeah, the green is the serialized metadata in the sort of standard format. So that's probably the most interesting thing to us. But what I wanted you to actually notice is more the stub. So that stub never got run, but we can set it to essentially anything we want as long as it includes this small segment of code. And that means we can prefix a valid archive with anything we want. We can put it in the stub, and that will be the start of the file. So we can fake a lot of file formats by simply putting data into the stub. Now, sometimes that might not be quite enough for us, and there's some interesting flexibilities in the tar file format that allow us to do something else. I'm not going to go sort of into the full details of that file format, but these are sort of the important points. And these two in particular. So the first 100 bytes of a tar archive is the file name of the first file in the archive. So that's quite flexible to us. We can change that, and we're simply changing the name of a file. And the end of the archive is marked by 1024 0 bytes. And anything after that is ignored. So this is quite useful for us to sort of make files that might pose as two different formats. So just to go through it really simply, here's another hex dump. This is of the start of a tar archive. And what I can do is change the name of that first file to what looks like gibberish. But if I go through, I've set the first 2 bytes to a JPEG header. The next 2 bytes say basically this is a comment within the JPEG file, and the next 2 bytes are the length of that comment. Now we can set that length to encompass the whole of the archive, and then just carry on a JPEG file afterwards. And because we've got those 1024 null bytes, the PHP, when it's dealing with the archive, will ignore everything after that, and something dealing with the image we'll see the archive essentially as a comment and everything else as the image. So hopefully I've got one of these on my desktop. So this is just a picture of my cat. You're missing some good pictures of my cat.
Yeah, we won't pop it. Sorry, I'll just reboot this. Oh, okay. Yeah.
I haven't prepared like a song and dance routine for this circumstance. So.
It's your HDMI.
Do you want me to try kicking it from here?
So we've got PC.
That's doing something.
There we go.
There we go. Right. Back to the important stuff. A picture of my cat. Right. If I change the file name of the picture of my cat, and open it with an archive program, we can see it's recognized it as a tar archive. Right. So it's got this unusually named file in it, but it's also got all the elements of a far file, which I mentioned earlier. So it's got the stub and the metadata, which is in the standard PHP serialized format. And it's got the signature, which isn't really sort of human readable. But so we can see that it's essentially a perfect polyglot. So the, depending on which application is using it, it views it as a perfectly legitimate sort of file of that format. Right. So I mentioned earlier about sort of file planting. So is there anything beyond just uploading a file to the target application we can do to get one on there? There's a couple of tricks from local file inclusion that we could use. I've referenced them there. So Brett Moore came up with a really cool technique with PHP info, whereby basically if you upload a file to a PHP page, it gets saved to the temporary folder, and the $_files array gets populated. And and PHP info outputs this, so it will tell us where that temporary file is. But as soon as PHP info has finished outputting, it will delete that file. But what we can do is sort of stall PHP info by refusing to receive its output once we've got what we need, and that will cause the file to persist for some time. Jimmy Ramsmark demonstrated that there's basically really low entropy in the names of these files on Windows. Sort of a bit of feedback I've had after I gave this talk last week at Black Cat has made me realize that one of the things I put up here isn't really feasible. So the session file stuff, you can only trigger this on a file which has an extension. So in Windows, the temporary files will have the .tmp extension, but in Linux they won't. And as far as I know, in both session files won't have an extension, and you can't trigger this issue on a file with no extension. And then finally, I've sort of mentioned log files there. I've not managed to pull it off, but in theory, it's possible. It's quite difficult we need to know the entire contents of the file to calculate a valid signature for whatever we're going to append on the end of that file or, in the middle of it. Okay, so in terms of identifying the vulnerabilities that are affected by this, it's essentially all XXE and a number of SSRF issues on PHP applications. I thought it was worth mentioning that there's an option which is sometimes used to protect against XXE, which is the nonet option, which says no network, because this is dealing only with local files, that doesn't protect against this. If we're looking to sort of detect the fact that we can use stream wrappers, in a black box way, it's much more preferable to use the FTP wrapper than the HTTP wrapper because it supports a lot more operations, and I'll demonstrate that shortly. If we've got no way to sort of connect out of band with ourselves, we can try using the file stream wrapper and observing the behavior of the application. So essentially, if it behaves a certain way with a valid path and we can chuck file : / in front of it, then that probably means that stream wrappers are working. Okay, so PHP GGC is basically why so serial for PHP. I've just taken all the good bits and written a couple of lines of code to basically put the payloads which are already included with that into a file archive using the techniques I discussed. Sort of quick note on the payloads. So to have them work with the demos I'm doing today, I'm doing most of them against the latest version of PHP. And there's kind of a defense in depth change that's been made. So you used to be able to dynamically call a function called assert, which would evaluate as PHP a string, but they've prevented you from doing that now. So I'm simply calling a function called pass-through, which calls out to a system command and spits the output out. If we're sort of attacking a hardened system and it has functions like pass-through or exec, band, most applications seem to use this library manager called Composer, and that includes a simple function which wraps include. So we could abuse that to include PHP code from another file. So all the case studies I'm going to go through today were found with manual analysis. 2 of them could have been easily found with the sort of FTP : / techniques I talked about earlier. And they all use just a simple uploading a file onto the target to place it there. Okay, so the first one I'm going to look at is a CMS called Typo3. Many thanks to a developer called Oliver Hayder who helped to fix the issue. So the code path from user input to where the vulnerability is fairly complicated, but the vulnerability is hopefully fairly clear from here. So where we end up is with file exists being called on a URL decoded value. So when it's trying to work out what type of path we're giving it, it's just the issue is when it processes links. But when it's trying to work out how to process the path, it does things like check if it's got colons or slashes in it and says, oh no, that's a remote file. But it does that before then URL decoding. So as long as we encode, for instance, the colon, we can trick it into thinking it's dealing with a local file and it will call file exists on a path completely under our control. So let's have a look at the demo. Okay, so the first thing we need to do is generate a payload. Like any sensible person, I've got lots of pictures of my cat in my pictures folder. In fact, first, if I run PHP ggc-l, this will list the payloads. No, it's not formatted very nicely. So I mentioned some of these are some of them are 2-string payloads, so we can't use them, with this exploit. But what I'm going to do is, so I'm taking as the input cat1.jpg, I'll output typo3.jpg. I'm going to use a payload called guzzlerce1, and I'm going to try and run the command uname-a. And I need to get my slash to that. Okay, so that's written into my pictures directory, typo3.jpg. So I'm running this demo just as admin. This CMS sort of implements a fine-grained access model, and it doesn't come with any standard roles or anything like that. The functionality I'm abusing would be accessible to lots of non-admin users. So Where's the file stuff gone? So I'm going to upload the payload that I generated earlier. And actually what I'm going to do I'm just going to listen on port 443 on a no, I'm not. So I'm listening on port 443 on another server, and I'm going to try and trigger the FTP Stream Wrapper to sort of demonstrate that Stream Wrappers are being activated. So if I go to any page and add some content, and I add an images element which has a link, as long as I encode that colon, I think I'm attacking. Let's try that. So that should hopefully. So that's connected back to us, and we can see that the FTP Stream Wrapper has been activated. I can do my poor impression of an FTP server, and we can see that it's trying to access XXXYYY. So if instead of using the FTP Stream Wrapper, we access that payload through the file Stream Wrapper, hopefully everything will work. Drop. Sorry. Let's refresh and do it again. What's going on now? Try again. I thought I was so clever when I fixed the demos to work not online. That's what it's done to me, right? Right. That's some silly thing. Right, this is the request. So somewhere down here, this would be saying the link to that file, and if we intercept the response at the top there, you can see it's triggered the payload. And yeah, that's the end of that demo. And so as not to make that mistake. Right. Okay, so the next demo is in WordPress, and when I first found this issue, so ultimately the issue is in PHP, but we need to find vulnerabilities in applications to exploit it. So I found this issue in WordPress and thought, oh, that would be a good one to demonstrate it, and thought they would fix it fairly quickly. You can see when I reported it, and it hasn't been fixed yet. I've ended up feeling that the only responsible thing is to disclose it as it is. So this is my favourite of the vulnerabilities because it's slightly more subtle. And this is ultimately where the vulnerability is. So it calculates this variable thumb file and it ends up calling file exists on it. But the way it calculates this variable is it takes this value file, calculates the base name of that, and it replaces every occurrence of that with this value thumb. And there's no guarantee that the base name of the file only occurs once. So what we're going to do is try and get it to replace the start of the file rather than just the end. So, right, this value file comes from this function getAttachedFile. And in most cases, that prepends the application's sort of upload directory to the file name. But in certain circumstances, it doesn't. So if the file starts with a slash, then it's a Linux absolute path. But if it starts with a single character, then a colon, then a /, then it's a Windows absolute path. So despite the fact that we're attacking a Linux system, we're going to give it a file path that looks like a Windows absolute path and, abuse this functionality to end up replacing the start of the file name and therefore activating the stream wrapper. In terms of the payload I'm going to use today, until fairly recently, so November 2017, there was a payload that I presented here 3 years ago, which went from toString to code execution. They've made some changes since then, and that payload's no longer valid, so we have to try and find another one. WordPress is quite limited in what classes you can use to construct these kind of payloads. So sort of looking through the classes that are there, there's one that really stands out, which is this request utility filtered iterator, which is an array iterator. So this essentially backs an array, and when you iterate through an array, this is the code that gets executed. And this uses a property defined callback. So if we control the object, we control this callback, and we can call any function we want with any argument we want. Now, this is obviously only triggered by iterating through the array. So we need to find something else to iterate through the array. I looked around, both the classes that are already loaded in WordPress and a few system classes, and couldn't find anything to do this. So the natural sort of next step is to look if there's any common plugins that have anything like this. And there's a very common plugin called WooCommerce, and that includes a class which has a fairly benign looking destructor because it's just for closing files. But the thing that it does that's useful for us is it iterates through one of its properties, so we can use that to trigger the other part of the payload. Right, let's have a look at this demo. Now, for this demo, I've sort of scripted it because there's quite a lot of, grabbing various values from various places. WordPress seems to run horribly slowly on my computer, so apologies. So I was just, this is the one case where WordPress has sort of predefined roles and stuff like that, so it's quite clear what user we can do this as. If I can log in as admin. Right. So this is the latest version of WordPress, and it has the latest version of WooCommerce installed on it. One of these should be users. And so I've set up a user called author, which is a member of the author role. So WordPress goes sort of anonymous, subscribers, authors, editors, admins. So, this issue is only exposed to authenticated users, but they're certainly not supposed to be able to execute code. Now, this should hopefully do everything for me. So the first thing it does is upload a file. It's doing it through XML-RPC, so the value is base 64 encoded, but we can have a look at that file in here. It's basically got sort of a JPEG header on it, but not much more. and then it goes straight into the stub and has our serialized payload in the metadata, etc. So it'll upload the file slowly. So it's uploaded the file, and then we need to just log in through the normal user interface to grab a cookie, basically. So hopefully that won't take too long, right? So it's logged in and got its cookies. We're going to use this one here as the admin cookie, or the backend cookie. So using that cookie, it's then going to access the page to edit the post that represents the file that we just uploaded. And we need to access that page to get something called a nonce, which we're going to need to do the next stuff that we need to do. So it's grabbing the value of this nonce here, and then it's using that, and it's setting the file name to z:/z. So when the code that we looked at earlier replaces the base file, it's going to replace the z at the end, but it's also going to replace the z at the start, because the start of the file is the same as the base file. That will eventually go through. So now it's going to set the thumb value to a far path to access the payload that we just uploaded. And now finally, when it triggers the thumbnail functionality through this XML RPC called to WordPress get media item. So hopefully if I intercept the response to that, down at the bottom, we've called uname-a again. And we'll see how fast it's feeding. Oops. We could, just to say, we could call any command. It might be too slow, so I'll leave that running in the background. We can have a look later. Okay, so the final case study is in a library called TCPDF. I'm going to exploit it through a CMS called Conteo, but really the important point is that this is in quite a widespread library. So as far as I know, this is the standard library in PHP applications to convert HTML to PDFs. And in quite a simple way, it sort of exposes the issue. So in a sort of standard application scenario, there's some situations where we might be deliberately given access to the HTML that's being sent to a PDF, but also we often find we can sort of cross-site script into some code that's then being rendered into a PDF. And the vulnerability is, like I said, quite straightforward. Essentially, it runs a tag handler through all the tags of the HTML, and if it encounters an image tag, it calls this function image with the source attribute, and that does a few things, but falls through to a file exists call with the value as we supplied it. So let's have a look at that one. So we need to generate a payload again. And we'll try cutting ETC password this time. again, it's the same as the first demo. It's you wouldn't need to be an admin to access all this functionality, but I haven't set up a bunch of users with the various different privileges. Right. So the CMS includes this article functionality, and there's a setting you can have on articles to allow them to be exported as PDF, which then uses the library. So I've got this article set up. I've just got the content set as XXXYYY at the moment. That should generate a PDF. XXXYYY. If I edit the content of that, so first I'm just going to put an image tag that literally references the image with no stream wrapper. What have I done? So I'm just using a relative path to the image in the code. Now if I save this, the HTML view of the article won't work properly because that's the browser is looking for that relative path and not finding it. But the PDF, oh, that's no good. Did I upload the image? Might help. If we try that again, we get a PDF with the image in it. And if I go back, so you can see it's still broken, you know, in the browser. Go back and if I put the file path in front of this, it's even more broken in the browser because that doesn't understand the file URL at all. If we send it to the PDF generator, it triggers the payload. Okay, so in terms of defending against this issue, obviously it would be ideal to avoid those types of vulnerabilities altogether, but bearing in mind that they were already known types of vulnerabilities and we're still finding them in applications now, that might not be that realistic. Sort of IPS's, IDS's, antivirus software should be able to detect this quite easily, you know, with signatures and things like that. It doesn't seem possible to disable the sort of behavior of that stream wrapper from the command line or php.ini, but you could potentially, you know, disable it during compilation. I've spoken to PHP about the issue a couple of months ago. I haven't heard back, but hopefully in the long term, they will address this issue. So what do I want you to take away from the presentation? More broadly than just PHP, we're seeing a lot of unserialization issues in multiple languages, and they're made a lot worse by, you know, I've said complexity there, but bloat is probably the right word. You know, people are adding libraries to applications and not worrying about whether they're used anymore or not, and not removing them. We're starting to see some libraries implement sort of defensive code, so trying to, you know, remove behaviors that are very useful for unserialization exploits. By abusing this stream wrapper, you know, we can exploit a number of different vulnerabilities, so XXE, SSRF. You know, certainly if certain settings are set, so for instance, allow URLF open is set to false on PHP, some of these issues you probably wouldn't even pick up and you would certainly report them as very low impact on a pen test. Now, hopefully, you realise they can be used to trigger code execution. And yeah, hopefully I've made it clear, sort of easy ways to identify the issues, either looking at source code or with black box methods. So I've added one slide from the talk that I gave last week, because a couple of people have pointed out to me that somebody else discovered this behavior and used it in a CTF. So a guy called Unsee set it as a CTF challenge, I think towards the end of 2017. I think as far as we're both aware, we both just discovered the same thing independently. And yeah, you often find that insecurity. People have the same ideas around the same time. So that's me all finished. Are there any questions?
Anyone got a question for Sam? No? Yep.
When you were basically injecting your injection into the JPEG, is there a possibility to actually insert a reverse shell so you could actually get a reverse shell back out of it?
Yeah, so what you could do, I mentioned about the assert stuff. So previous to PHP 7.2, it was really easy to, with these kind of unserialization payloads, to run arbitrary PHP code, which obviously you could write a whole reverse shell and contain it within that JPEG. I mentioned the composer's got a wrapper for include file. So if you were looking to execute sort of more complicated code than just running one command, what you could do is embed in that JPEG a whole PHP source file as part of the archive, and then include that with the sort of composer wrapper function, and then you'd be running a whole whatever you wanted. But yeah, reverse shell would probably be the
ultimate
one good thing. Yeah. Any others?
Anyone else? No? Okay, give it up for Sam.